Okay.
Hi, my name is Matt Whelan,
I'm Joshua Giacconi.
I'm Zach Allen.
and we had the pleasure to construct a heating and dehumidification recommendation report for the Swanton Pacific Railroad. We would first like to express our thanks of gratitude to Larry Sun, Andres Lujan, Professor Poiker, and Professor Mott for their contributions to this report.
So a little bit about the site. The Swanton Pacific Railroad exists on the 3,200 acre Swanton Pacific Ranch located in Davenport, California in Santa Cruz County and lies within 2 miles of the Pacific coast. The buildings in the scope of our work are the roundhouse where the locomotives are stored, the machine shop where the parts are worked on and assembled, and the car shop where the cars towed by the locomotives are worked on. The site is maintained by a group of dedicated volunteers who work weekly to preserve the trains and the railroad. The location provides a cold, humid environment with humidity that varies between 80 and 100% and gets as cold as 37 degrees in the winter. These conditions provide many challenges to maintaining the locomotives, especially having to dehumidify the space to prevent condensation. The age of the buildings also provides their challenges because most of the heat that does exist in the buildings leaks out through the cracks of the walls and the roof.
All right, for our project requirements, as Zach had said previously, we're trying to control humidity levels within the space. So the main problem we were tasked with was solving for the roundhouse and the machine shops and finding a way to dehumidify and maintain the humidity levels within the space. And secondly, being able to heat up the space for more desirable working conditions during working hours. This would reduce condensation in the space and help prevent rust on the locomotives, parts, and equipment. For the car shop, humidity control was not desired and localized heating options were explored to raise the temperature for more desirable working conditions. In the upper right of the PowerPoint, you can see that is the roundhouse. In the bottom right, we have the machine shop, and the bottom left is the car shop, which is currently all closed up. To explore infiltration solutions, due to the age of these buildings, they're currently all very leaky, which leads to a problem when trying to control the humidity level in a space. There's some small improvements that will make a big difference that we can make, such as replacing all the single pane windows with gas-filled double pane windows that have a low E coating and a low U factor. Replacing all the doors and tightening up the clearances between the doors and the framing will help for a tighter seal. Within the roundhouse, sealing off the exhaust and smokestacks when they're not in use. In the upper right, you can currently see there are 3 smokestacks that are currently always open, and they're not always used. So if we can seal them up when they're not in use, that'll help significantly with infiltration levels. And then on the same regard, on the bottom right for the machine shop, it used to be an old Boy Scout kitchen. That's a kitchen exhaust fan right there, which we recommend they would remove or completely seal off entirely. Adding brush seals along the bottom of sliding doors would help, and adding a waterproof barrier, kind of like a foam, on all the tracks where the tracks meet up to help seal those off from under the doors. And other small things can be done, such as patching up walls and sealing up all the holes and gaps between structural surfaces, such as with spray foam.
Now, the mechanical solution for the machine shop and roundhouse, we quickly determined that a heating system alone wouldn't be able to deal with the humidity control of the space. We were also worried that a standalone dehumidifier wouldn't be able to handle the humidity due to the operating conditions. So with some help from professionals in industry, we decided on a split system heat pump with an air handler. This system would be able to safely operate down to an ambient temperature of 35 degrees Fahrenheit. A nice feature of the system is that it bleeds off refrigerant from the compressor to reheat the dehumidified air, thus saving money in the reheating process. An additional electric heating element was added to raise the air temperature to the desired set point. Lastly, the system can operate in different modes. One such mode is the humidity control mode, where the system will provide minimal heating to the space, but maintain the desired humidity levels to prevent rust. Another mode is humidity and heating control, where workers can increase the temperature within the space to a desirable level and maintain the necessary humidity levels.
The solution for the car shop is a little bit different than the roundhouse and the machine shop because the car shop requires no humidity control. So our solutions are solely concerned with heating the building. The current heating situation is spot heating using standing propane heaters around where the volunteers are working. And these work fairly well, but there aren't enough of them at the moment. Our best solution is a portable forced air heater that provides 50 kilowatts of heating. A propane tank of at least 100-pound capacity is necessary to support this heater, but the unit can be easily moved and adjusted at all times. This unit has plenty of capacity to heat the space to desirable indoor conditions in fewer than 2 hours. Another viable solution are wall-mounted infrared heaters that provide 6 kilowatts of spot heating over 160 square feet. For this solution, 8 units would be spread 10 feet apart along the walls nearest the volunteer workspaces. This solution requires a major electrical upgrade though, and so is a more taxing solution. The final solution is to continue using standing propane heaters to heat small areas around the volunteer workspaces, but these units are not as efficient use of the space for how much heating they provide, but they are cost effective. We hope you learn more about our Swanton Pacific Railroad project. Continue through the page to find more about the detailed solutions, and thank you for listening.